we're going to do expanding three brackets is an extension from what you learnt last year with quadratics. So last year you took two brackets and you expanded them out. And the rule was that you take each term in the first bracket and multiply it by each term in the second bracket. That yields 4 terms, which is what they call quadratics, and then you add the like terms. Well, 8x and 3x are like terms, so we add them together to get 11x. This year we add another set of brackets, but the same rule still applies. Each term is multiplied by each term in each set of brackets. However, we don't want to do all of that in one step because it's far too confusing and far too likely to make a mistake. So we break it down into 2 steps. And here we go. We'll take an example, very easy one to start with. X plus 5, x plus 6, x plus 2, and we're going to multiply them together, and we're going to pick 2 of them to go first. And it doesn't matter which pair, multiplication, the order doesn't matter, so any 2, and we'll take the last 2 because it makes life easier with the one out the front. X squared plus 3 and 2 is 5, 3 times 2 is 6, and now we take the x plus 5 and we multiply it into the second bracket. We multiply the x in first and then the 5 into each of the terms. So we're going to get 6 terms, and here they are. Now, just as we did with 2 brackets, we have to add like terms. But the problem is when you write them out like this, that the like terms are not beside each other, and it's very easy to make a mistake, especially with negatives. So what I suggest you do, very, very strongly, is you don't write out your answer like this. Instead, you do the first multiplication and stick them out there. Then you do the second multiplication underneath, lining up the like terms. So that drifts across one. Now it's extremely easy to add up like terms because they are in vertical columns. We have x cubed, 13x squared, 52x plus 60. You're much less likely to make a mistake if you do the multiplication in 2 stages and line them up. And I'll show you why on the next one, which is much more like one you're likely to face. So you're likely to get leading coefficients and you're going to get negatives every time. So what I suggest you do is you multiply any 2, but life is a lot easier if you multiply the difficult ones first. So we're going to get rid of the negatives and the leading coefficient, and we're going to leave ourselves with the simplest one to last. So you can do any pair, it doesn't make any difference, but if you leave the easiest one out, then life is simpler and you'll make less mistakes. So I'm going to rewrite it with x plus 4 left out, and I'm going to multiply the next 2. So here we are, 2x goes into x and minus 2, 5 goes into x and minus 2, and that's our answer. We then multiply out the x plus 4, first step, multiply out the x, second step, multiply out the 4. Because I've left that as a positive, I don't get any awkward negative multiplications, and I've lined them up, and so adding them up is pretty simple. And then, because this is really easy to make a mistake, especially with the negative 10s and plus 4s and all the adding, you want to check our answer on the calculator. So how do we do that? Well, we take our coefficients in the polynomial solver of the calculator, and you should end up with what you started with. I'll show it how it's done. That's what we've just done. Let's check it. We take our calculator, and in menu we go to equation. That's where all our solvers are, and we're checking a polynomial. This is a polynomial, and it's degree 3 because it's an x cubed. So we have 2x cubed 9x squared minus 6x minus 40, and when I solve it, I'm returned with the original factors. X minus 2, 0 when x is equal to 2. X plus 4 is 0 when x is equal to minus 4. And 2x plus 5 is equal to 0 when x is equal to minus 2.5. So I get the opposite, the solutions for my factors, so I must have done it right. And that's our method. We multiply any two brackets, but it's best to leave the nice simple positive one out at that stage. Do the other two. And you multiply the x component of your remaining bracket into what you've expanded, and you multiply the number term in, but you line it up so that like terms are below each other. You add the like terms, you must always add the like terms, just as you had to do with quadratics, and then you check it using polynomial solver on the calculator.